Question 1. A, write down the t formulae for sine. So for this, it's just 1 mark, so we just need to state our answer. So for this, we know that for part A, sine x is equal to 2t over 1 plus t squared. It's only 1 mark, so we don't need to prove anything. We just need to be able to write down that statement. B is split into 2 parts. So the first part is telling us to use the answer to part A to find the exact value of sine x when tan of x over 2 is equal to root 2. And then we show that cos x is equal to 1 minus t squared over 1 plus t squared. So focusing on the first part, so B, part 1, we know that if tan of x over 2 is equal to root 2, that is implying that t is equal to root 2, because we know that t is tan of x over root 2. So therefore, using our answer from part A, it says sine x is 2 lots of t, so 2 lots of root 2, all over 1 plus t, or in this case root 2, squared. That tidies up to 2 root 2 over 3. That's our exact answer because we've got our surgeon there. We've not done any rounding throughout. Part 2 says to us, show that cos x is equal to 1 minus t squared over 1 plus t squared. So there's a couple of ways that we could do this, but we have to show that. So we can't just state it. So we can start from knowing that tan x is sine x over cos x. We can then rearrange that by multiplying up by the cos and dividing through by the tan to tell us that cos x is therefore sine x over tan x. We know what sine x is from part A, and we also know what tan x is because we can just state that. So sine x is 2t over 1 plus t squared, and tan x is 2t over 1 minus t squared. When we tidy that up, we get 1 minus t squared all over 1 plus t squared as required. For the next part of this question, for part C, we are asked to use t formulae to solve for 0 to 360 for theta, 7 sine theta plus 9 cos theta plus 3 is equal to 0. Give your answers to 1 decimal place. So in order to do this, we're going to turn these into terms of t, and then we can solve and go from there. So for C, starting off with 7 sine theta plus 9 cos theta plus 3 is equal to 0. I can replace the sine with 2t over 1 plus t squared. The cos we can replace with 1 minus t squared over 1 plus t squared. 3 is just going to stay as a 3 for now, is equal to 0. In this next step, I'm going to do 2 things. I'm going to multiply out each of these brackets, but I'm also going to multiply the whole expression through by 1 plus t squared. That's going to give it all on one line. So multiplying out this bracket here, I'm going to get 14t. Then I'm going to get plus 9 minus 9t squared from the second bracket. And then by multiplying up by 1 plus t squared, it's going to cancel this denominator. It's going to cancel this denominator, but it's going to give me 3 plus 3t squared. Multiplying the other side, 0 times anything remains at 0. So then we can tie this up. We're going to get 12 plus 14t minus 6t squared is equal to 0. I can see they're all even, and also I want to get this t squared to be a positive, so I'm going to divide through by minus 2, giving me 3t squared minus 7t minus 6 equals 0. I can then factorise this into 3t plus 2, and t minus 3 is equal to 0. Then solving for t is either equal to minus 2/3 or t is equal to 3. So now we're going to solve for t, but we need to remember that t is tan of x over 2, or theta over 2. So when we're looking for our solutions, we're no longer looking between 0 and 360. We're now looking between 0 and 180 because it's theta over 2. So I've halved the range which I'm looking in. So we know that t is equal to tan of theta over 2. So solving this, we know that theta over 2 is equal to arctan, or tan to the minus 1. Obviously, they mean the same thing, of minus 2/3. From here, I'm going to get my principal solution. In my calculator, I get minus 33.690,06753. Well, that's not within my range of 0 to 180, so I need to find my next solution. So we can do this using cast or just knowing how tan behaves. So we're going to add on 180 to that to get 146.3099,325. That is in my range, so I'm going to discount this one, but I am going to keep that one. We're also going to just explore what the answers are when we do treat t is equal to 3. So this time theta over 2 is equal to inverse tan, or arctan again, of 3. That gives me a solution of 71.5650518. That's within the region. If I did add on 180 actually to either of those two solutions that we've just found, which is the region, I'm going to be outside of the region because it's only between 0 and 180. So that's also in there. So now what I'm going to do is I'm going to try and find theta. So we know theta over 2 is equal to 71.565, so on, or 146.3099, so on. So I'm going to double both of those values. Doing so, I'm going to put them in size order, in ascending order. So doubling the 71.5650518, I get 143.13011024. Doubling the 146 answer, I get 292.6198649. Now, it did say in the question right at the end, leave your answers to one decimal place, so I'm now going to round. So 143.1 degrees, or 292.6 degrees to one decimal place.